Hello everyone, this is 8.2.2 Classwork, numbers 78 through 81. I made a small change in the video. There will be a green screen like this in between each question. So if you only have a problem with one of the questions, you can scroll through the video, and when you see the big green screen, that means that question's over and a new question is coming up. Here's our first question today. Alice has a 4x5-inch photo of her school's championship girls ice hockey team. To celebrate their victory, your principal wants Alice to enlarge her photo for a display case near the main office. When Alice went to the print shop, she was confronted with many choices of sizes: 7-inch by 9-inch, 8-inch by 10-inch, and 12-inch by 16-inch. She's afraid that if she picks the wrong size, part of the photo will be cut off. So, what size should the new one be? Well, if we have a rectangular picture, and if the first one is 4 by 5, and I need an enlargement, in order to keep them similar, the ratios of the corresponding sides must be the same. So, let's say that I'm going to take and multiply this side by 2, that will give me 10. If I multiply this side by 2, that will give me 8. So that means that this will be a similar shape, and that's the one that we're going to need to do. So if I multiply the two dimensions by the same thing, that will give me the new shape. So the correct answer is 8 by 10. We know that Alice's enlargement is going to be 8 by 10. So the cost of the photo paper to print Alice's 4 by 5-inch picture is $1.50. Assuming that the cost per square inch of photo paper remains constant, how much should it cost to print the enlarged photo? And then explain how you got your answer. Well, this is going to go back to the idea that we have a linear ratio and we have an area ratio. The price is based on the area ratio. We know the linear ratio will be 4 over 8 because the lengths of the corresponding sides are 4 and 8 from the small to the big picture. That will reduce to 1/2. So my linear ratio is 1/2. To find my area ratio, you take the linear ratio and you square it, so that will be 1/4. Since the area ratio is 1/4, that's proportionate to the cost. The original, or the small photo, costs $1.50, so I need to figure out what the large one will cost. When you cross multiply, I'm going to get that x is equal to $6. Unbeknownst to her, the vice principal also went out and ordered an enlargement of Alice's photo. However, the photo paper for his enlargement cost $37.50. What are the dimensions of his photo? So again, now we're talking about the area ratio that we're given. Since the price is based on the area, then that means I have to compare the prices. The original price was $1.50. The enlargement cost $37.50. So I need to reduce that fraction. When I reduce that fraction, it equals 1 over 25. That means to find the linear ratio, I need to take 1 over 25 and do the square root of that. That's going to be the square root of 1 over the square root of 25, which is 1 over 5. So my linear ratio is 1 over 5. In other words, the large photo, the new enlargement, is 5 times the size of the original. So when it's asking for the dimensions, if the original dimensions were 4 by 5, then I have to multiply each one of those by 5, and that will give me the new dimensions. So my new photo will be 20 by 25. So that's going to be the answer that you're going to select out of the drop-down menu. That problem's done, and the next problem is 8-79. Okay, let's take a look at 8-79. It says, so far you have discovered and used the relationship between the areas of similar figures. How are the perimeters of similar figures related? Confirm your intuition by analyzing the pairs of similar shapes below. For each pair, calculate the areas and perimeters and complete a table that looks like the one shown below. To help see the pattern, reduce fractions to lowest terms or find the corresponding decimal values. The very first thing it's asking us to do is find the ratio of the sides. So I need to look at the corresponding sides. So 36 and 108 are corresponding sides. Because it's the length of a side, that's going to give me a linear ratio. I'm going to do the small over the big, which is 36 over 108, and then I need to reduce that fraction. That fraction reduces to 1 over 3. So I'm going to put that as a fraction in lowest terms with the small over the big. Now, to find the ratio of the perimeters, that means I have to calculate the perimeters. To do that, I have to find the missing side here. I'm going to use my linear ratio to do that. So I'm going to set up a proportion. I'm going to say 1 over 3, which is the ratio of these two sides, has to equal 5 over x, which is the ratio of those two sides. When you cross multiply, you end up with x is equal to 15. So to find the perimeter, I know that this side's 15, this side's 15, and this is 108. That's 36, this side's 36, and this side is 5. So when you add those all up to find the perimeter of the small one is going to be 82, and the perimeter of the large one is 246. Now, if you write that as a fraction and reduce it, that also reduces to 1/3. Next, we need to find the area of each one of them. To find the area, you just multiply length times width. So the area of the small rectangle is going to be 5 times 36, which is equal to 180, and the area of the large rectangle is going to be 15 times 108, which is going to equal 1620. So my area for the small figure is 180, the large figure is 1620, and when you reduce that fraction, that reduces to 1 over 9. So again, if you look at the ratio of the sides compared to the ratio of the perimeter, they're the same because they're both a linear measurement. You measure them both with a ruler. And then to find the area ratio, you square that. So again, we would take 1/3 squared, and that equals 1/9. Done with another problem, you made it through. The next one we're going to look at is 8-80. Looking at 8-80, while Jessie examines the figures at right, she wonders if they are similar. Decide with your team if there is enough information to determine if the shapes are similar. Justify your conclusion. Well, the first thing I'm going to do is take a look at the ratio of the sides. That is my linear ratio. So that's going to be 4 over 12. When I do 4 over 12, that reduces to 1/3. So that will be the ratio of my sides. Next, I need to find the ratio of my areas. That's my area ratio, which will be 60 over 540. When you reduce that fraction, that reduces to 1/9. So when we compare the linear ratio and the area ratio, if I take the linear ratio and square it, I get 1/9, which is the area ratio. So you might think that these are similar because those ratios match up. However, just because the linear ratio and the area ratios are the same does not necessarily mean that they are the same shape. Let me give you an example. If you were to take a look at two triangles, let's say that this is 10 and this is 5. Let's take a look at another triangle where the base is 10 and the height is also 5. Now, these two triangles will have the same base, the same area, but they're not similar because they're different shapes. The same idea could be said if you wanted to make this twice as big here and make this twice as big here. So now the ratios of the two bottoms will be the same. The ratio of the area will be the linear ratio squared, but again, those are not the same shape. So you don't necessarily have similar figures just because the linear ratio is the square root of the area ratio. Okay, 8-81 is next. We're flying through these. Okay, last one for this lesson, 8-81. Your teacher enlarged the figure at right so that the area of the smaller shape is 2,720 square centimeters. What is the perimeter of the enlarged figure? So again, we have to look at two things. We have to look at the linear ratio and the area ratio. Because I'm given the area of the small shape, which is 170, and given the area of the new shape, which is 2720, I can reduce that area ratio, and when I do that, it equals 1 over 16. Then to find the linear ratio, I need to do the square root of the area ratio, which is the square root of 1 over the square root of 16, which equals 1 over 4. So that means my linear ratio is equal to 1/4. So now I need to find the perimeter of the original shape. To do that, all I need to do is add together all of the sides. So if I add 18 plus 18 plus 4 plus 8 plus 4 plus 4, I'm going to end up with 56. Now, that's the perimeter of the small shape. So when I set up my proportion, I used my linear ratio, which is 1 over 4, and set that equal. Now, the small shape has a perimeter of 56 over the large shape. This is the new one that I made. So when I cross multiply, I get that x is equal to 224. That will be the perimeter of my new shape. You made it to the end. Congratulations, and have a good day.